In this video, we are going to learn lesson 4.3, which is about writing equations in point slope form. And point slope form is a different form than what we have been working with. And we will have a new equation to memorize for that. Following this, you will have the 4.3 homework worksheet. Okay, so at the top of this paper, I have all three formulas that you will need to have memorized. So this one we know so far. We know slope-intercept form is y equals mx plus b, and the m stands for our slope, and the b stands for our y-intercept. Point slope form is the new one that we're going to learn today. So you know how this stayed a y? This is the one that's going to stay a y also. It's not going to be a number. And x stayed x. This is the one that's going to stay the variable. The point that we have is going to go into this spot. So the x1 and the y1 correspond to an ordered pair that I'm going to give you. And then m is going to refer to the slope as usual. And then standard form. Standard form is a very useless form. It does not tell us any information about a point or a slope. The x and the y are going to stay x and y, and the a, b, and c are going to be numbers. But in this form, the a, b, and c do not represent a point, a slope, anything. It's just a very typical way that equations are written when we're not talking about graphing. But we're going to play around with it a little bit in this lesson. So here in example 1, it says to write an equation in point slope form. I highly recommend underlining whatever, because in a quiz or test it might be a bunch of different questions that have the same kind of look to them, and one might say point slope form, one might say slope-intercept form. So make sure you know that point slope form is the one that we are using for this one. So I want it in point slope-intercept form, or I just mixed two words together, point slope form, and then it's going to have a slope of 1/4 and it passes through this point, and then we're going to graph the equation from there. So basically it's going to look like y minus blank equals blank times x minus blank. So in those spots you're going to write your slope, which goes right here. And then your point is going to go, so that's your x1 and your y1. So x is going to be here. And then when you plug in that -2, it's going to turn this into a plus sign. So y plus 2 equals 1/4 times x minus 3 is what your answer is for the equation written in point slope form. So it says to graph it, and the way that we're going to do that is very similar to how we did it in slope-intercept form. You know how we would start with the y-intercept by graphing that first, and then use the slope to graph my points? Well, here we're going to start with the point that's given to us. So if we graph point 3, 2, -2, that would just start right here. And then from there you're going to go up 1 and right 4. So we don't have graph paper, so I don't expect you, if I don't give you graph paper, to make it perfect. I just want a general idea. So if I went up 1 and right 4, that might look something like that. And then down 1, left 4 would look something like this. And that would be approximately what the graph would look like. So go ahead and try the guided practice with the same directions of writing it in point slope form. Okay, so if I'm writing this in point slope form, it's y minus y1 equals m times x minus x1. That's going to turn this into a plus sign. So that's my equation written in point slope form. And if I'm graphing that picture, approximately, okay, -2, 1 would be about here. And if it's -6, that means I'm going down 6 and then right 1. So maybe like here. Or I could go up 6 and left 1, so maybe about there. So this is going to produce a steeper line than before because the number 6 just makes that really steep in the rise. So one thing I do want you to notice, we'll talk about this later, the slope when it's negative is going down from left to right, and then that's like what our guided practice had, and then our example had a slope that was positive, so it goes up from left to right. So that's one way to kind of quickly check did you graph it correctly, is if it's at least going in the right direction. Okay, so for example 2, it says to write the equation in standard form. So that's the one that we talked about up here, the ax plus by equals c. The x and y stay those variables, and the a, b, c are going to be numbers. So I made a note here. Standard form is picky. It must be in that exact order. Of course, all the equations and formulas must be written in the order given. But a must be a positive number. And a, b, and c must be integers. And integers is the definition of a whole number. It could be positive or negative, but I guess I can't say that a is an integer. It has to be just a positive integer. So let's take a look at what that looks like. So I'm going to write standard form right here to remind us of our goal. So basically we want the term with the x and the term with the y on the left side of the equation. So if I'm doing that, what that would look like so far is at least moving this to be on the left side of the equation with the y. C stands for the number without the variable, in this case the 4. And that is actually good on the right side now. So on the left side, I'm not going to write y plus 3x, even though I normally probably would have done that if I was just moving things around. But it has to be in that exact order. So I'm going to put the 3x first, and it's a positive y, so then plus y. And that one is actually finished. That one's nice. So let's move to this one. So a must be positive. We can't have fractions or decimals. And we have a fraction here. So in order to get rid of fractions, the trick is to, okay, because like this is dividing by 3, the opposite of dividing by 3 is multiplying by 3. So let's multiply this by 3. And what you do to one side, you have to do to the other. So this side also gets multiplied by 3. So what that actually does here is just cancels that out. And then this we can distribute. We'll do that on the other side too then. But we have to basically, if we're going to multiply the one side by 3, also multiply this side by 3. And now I'm going to distribute. That's going to turn into a plus 10 because it's negative times negative. Okay, so we reached the goal of getting rid of the fraction. Now we need to get it in the exact order. So let's move this to the other side. And let's move this to the other side. Okay, so the number without the variable is on the right side. That's going to be a 13. And then I'm going to write the 2x first and then the 3y. And now it's in standard form. Okay, in this guided practice problem, there's not a fraction, so we can go right to just distributing. So 7x plus 35. And then y minus 1 is on the other side. That didn't change yet. But I will move this 1 because that's our c term. And our c term is going to be a 36. And then I'm going to move this 7x to be on the other side. Now, we run into something here that we have not seen yet. Our a term is negative. So basically what you would do here is multiply both sides by -1. And what that translates to is changing the sign on every term. So it's going to be 7x, that's positive, now a negative y, and a -36. So that would be your final answer there. So A must be positive. All right, so moving on to example 3, it says to write this equation that's given to you in slope-intercept form. So it's given to you in point-slope form, right? And remember here, fractions are okay since we're talking about slope again, and slope is a fraction. So we don't have to think like we did in that last example. We can keep that fraction. So if we are getting it into slope-intercept form, our goal is to have y equals mx plus b. So I would distribute first. So we'd have 3 over 2x plus 3 over 2. And the only thing out of place here is this 3. So I'm going to move it to be with this. So now you have a couple options here on how you want to handle the fraction with the whole number. So really 3 over 2 is 1.5. So you could say 1.5 minus 3 is negative 1.5. Or really, it kind of like, you don't see it too often in a math textbook that like a fraction is mixed with a decimal in the same equation. So really, I would change that to back to a fraction. It wouldn't be wrong to write it as a decimal. The y-intercept can be written as a decimal, so as long as the slope is written as a fraction, you're good. So that would be your final answer there. All right, so go ahead and pause the video and try the guided practice. Okay, so this guided practice problem has the same directions. It's given to you in point slope form and it wants slope intercept form. So we can distribute. So negative 3x plus 12. And then y plus 6 is still on the other side, did not change. The 6 is out of place because we just want y by itself on the left. And that 6 gets grouped with the 12 because they're both constants. And that's your final answer. All right, now for some application with these equations. It says that there's a figure shown called RSTU, so that is just how we name shapes, is by their endpoints letters. And it says to write an equation in point slope form. So that's the y minus y1 equals m times x minus x1 form. And it's for the line consisting of side TU. So that is this side right here. So when we did these before, we needed to plug in a slope and we needed to plug in a point. So this is going to be a little interesting because it doesn't matter which point we use, and here we have 2 points. So point U is at 1, 2, 3, 4, 1, 2. So that's at 4, 2. And T is at 7. So this was 2, 3, 4, 5. So that's at 7, 5. So we know how to find the slope between 2 points, right? So you can do that by doing y2 minus y1 over x2 minus x1. So that would be 5 minus 2 over 7 minus 4. So that's telling me that our slope is 3 over 3, which simplifies to 1. And you could actually verify that by just looking at the graph too. We didn't need to do slope formula because we can count that it rises 1, runs 1. There's actually points in between. Rises 1, runs 1. And again. So you can choose to use the slope formula or just count rise and run on a graph. And now that we know that that's our slope, we can basically be done and write our equation in point-slope form. So if we are using point U, we would be saying the y-coordinate is a 2, the slope is a 1, and it's x minus 4. But if this was like a quiz or a test, I would actually have 2 answers that are correct on here, which usually doesn't happen too often in math, because we could also use point T, which would be y minus 5 equals 1. The slope would not change. And then x minus 7. So both of these are correct options for the answer. Now it says to write an equation in slope-intercept form for the same line. So here's what I would recommend doing. It's kind of like what we just did in the last example. Take the equation of either one. I'm just going to do this one. And distribute. So it'd be x minus 4. And then we would add 2. And that would be your answer right there for the equation written in slope-intercept form. Now, I just want to prove a point to you. If we also chose the other one, we would still get the same answer. So distribute, and you're going to get x minus 7. And then we add 5 to the other side. And we're going to get y equals x minus 2. So same thing again. So that's just to show you it doesn't matter which one you choose, because slope-intercept form is going to be always the same every single time, because the plus b is talking about the y-intercept, and there's only going to be one y-intercept for this equation of this line. And point-slope form has so many options that it could write, because there's more than one point on a line. Alright, so the guided practice is asking you to write an equation in point-slope form for the line containing ST, so I'm going to do all that in, let's do it in red. So ST is this line here. So my slope, I'm just going to count, is going down 1 and right 1. So my rise over my run is negative 1 over 1, which reduces to negative 1. And then the ordered pair for t we already had. We can use the same ordered pair. But s has a different ordered pair, so we have 4, 6, 7, 8. So one of the options could be, if we're talking about point S, y minus 8 equals negative 1 times x minus 4, or we could talk about point T and say y minus 5 equals negative 1 times x minus 7. Now this one is asking you not to put it in slope-intercept form. This time it's asking you to put it in standard form. So if I take y minus 8 and go to put it in standard form, remember that's the ax plus by equals c. So I'm going to distribute negative x and positive 4. So now I want to move the 8 with the 4 and the x with the y. So it'd be x plus y equals 12, and that is an okay form for standard form. The a term is not negative, they're all whole numbers, and they're in the exact order. And you could have also done the same thing and taken the second one, and I'll do that real quick here just to show you. I'm going to distribute at the same time. Okay, so then if I add 5 to 7, I'm going to get that 12 like I did over there. And then if I add the x, it's a positive x, just like it was over there. So you'd get the same answer. So you don't need to do them twice. However, if you wanted to make sure you were 100% correct, you could do them twice. And then same for the guided practice, the first one, for 4A. You don't need to give me both of those. You would only have to give me one. So that is everything you need to know for lesson 4.3. I would recommend going to make note cards for the other formulas that you have to memorize. That way you can just study them every now and then.